hopefully you had an opportunity to work through this problem. And so we basically have a list of grouped data that's been put into a frequency distribution. And our goal is to be able to characterize that group data by finding the mean and the sample standard deviation. So we have a list of grades earned on Math 216, and it looks like the teacher just basically put them into bins based on grade A, B, C, D, F. All right? And we would just want to find the mean and the standard deviation for that data. All right? So first thing we're going to do is we're going to get n. All right? So we're going to add these up. So we have 12 and 22 and 24 and 25. All right? So n is going to be equal to 25. Of course, if you don't believe me, what you could do is you could certainly go into your calculator, 5 plus 7 plus 10 plus 2 plus 1, and that gives us 25 as well. All right, so if you don't believe that, well, you might have some trust issues. Next thing we're going to do is we're going to start setting up the table to be able to find the sample mean and standard deviation. Hopefully you went through and you started with the class, which was 100 to 90, and then 90 to 80. 80 to 70, and then 70 to 60, and then finally 60 to 50. And we need a midpoint, all right? And hopefully you could very easily see that the midpoints for each of the classes, 95, 85, 75, 65, 55. And remember the trick, if you don't remember how to find, if you can't inspect or just see what the midpoint is, you just do 100. Plus 90 divided by 2, which is 195, or 190, excuse me, divided by 2. And that's going to be equal to 95. And of course, if you don't believe me, just throw that to the calculator. All right. Next column, frequency. All right, so we're just going to copy the frequencies that we just got from above. So 5, 7, 10, 2, 1. Next column, m times f. All right, so we're just going to multiply. So in our calculators, we can do 95 times 5, and then 85 times 7, etc. All right, so those are going to be the values that we're going to go through and substitute into our column. All right, so I'm not going to do all of them, but I figure you guys can, if you've seen the first two, you'll be okay with that. So that's 475. And then we had 595. This one's clearly 750. This should be 130, I believe. And then the last one, 55. Last thing we're going to do is we're going to add this column up, and that's going to be the sum of m times f. Right? So in our calculator, what we can do, just to verify this, 475, 595, 750. I think we had 2 times 65, which was 130, and then 55. We should end up with 2005. So, and we're getting close to being able to find our sample mean. Right? So this is going to be 2005. Not whatever that character is, 5. And then finally, we just go through. Continue a little bit of room here. So let's get some room to make this work. And so x bar, we have our formula, is the sum of m times f divided by n. So that's going to be our 2005 divided by n. Remember, we found n was 25. All right, so we just got it from right here. And we're just going to throw that into our calculator. So 2005 over 25. And before we get the answer, let's think of what the answer should look like, okay? Because if it doesn't look like it, then it probably doesn't make a lot of sense. All right, so we go to our data. And remember, the range of our data was from 100 to 50. Most of the data is between 100 and 70. All right, so we should probably get a number somewhere between 100 and 70. There are a couple observations of 70 to 60 and 60 to 50, but most of them are between 100 and 70. All right, so if that doesn't make sense, make sure you email me. All right, we get 80.2. Clearly, that's a number between 100 and 70. All right, so in our estimation, the sample mean of 80.2 makes sense. All right, or hopefully it makes sense. All right, now we found the sample standard deviation. Right? The next thing that we're going to do is we're going to find, I'm sorry, we found the sample mean. Next thing we're going to do is define the sample standard deviation. And to do that, we need a couple more columns. All right, so I'm going to erase some of this stuff so we have some adequate room. Hopefully when you work this through on your own, the next column you computed was m squared. All right, and it's going to be a big one, right? So we're going to have 95 squared and 85 squared. So 95 squared, and then 85 squared, and then 75 squared. So you're just going to go through and compute all of those. All right, 65 squared, and then finally 55 squared. All right, and we're just going to copy those into our data. So we end up with 9025, and then 7225, 5625, 4225, and then finally we have our 3025. All right, now the last column, and this is going to be the really big numbers, m squared times f. All right, so when you were doing these, if you got big numbers, make sure you understand that that's okay. All right, and just to remind you, where we got m squared from, we just squared each of the m's. To get m squared f, what we're going to do is we're going to multiply the frequency times m squared. So we're just going to multiply those two columns. So that's going to be, just for instance, 9025 times 5. All right, and so I'll do this in the calculator. So 9025 times 5. All right, and so notice we're getting these really big numbers. All right, remember we had 7225, and we're going to multiply that by the frequency of 7. All right, now I'm not going to do all of these, but I'm just illustrating that this is how you guys would go through and get that m squared f column. All right, so I'm going to copy all the values in. So erase this. And so we have 45,125. And then we have 5575 and 56250 and 8450 and 3025. Oh, sorry, 16,000. Right, since we have to do m squared times f, that should be 3025. All right. So finally, we're going to go through and we're going to add those numbers up. All right. So let's just go in our calculator. We can add those up. So we have 45125, and then we have 505 plus 75, 505, 75, 56250, 8450, 3025. All right, so we end up with 163,425. Pretty gnarly number. So 163,425. And remember what this is. This is our sum of m squared times f. And so what do we do with that? Well, we're going to throw it into our formula. All right, so I'm just going to copy this. So that way we know what we're looking at. And so when we substitute everything in, we're going to get the square root. M squared f is going to be that 163,425 that we just got. And then we're going to square the sum of mf. So hopefully when you work this through, you had 2005 squared. Remember, we had 25 as the n, right? So that's this value is n, and then finally n minus 1 is 24. Remember, the trick for doing this at this point is to just shove this into your calculator. All right, so you're going to figure out the numerator first. You're not going to try to find everything at once. That generally leads to syntax errors in your calculator. So you're going to take that 163,425. You're going to subtract from that 2005 squared, and you're going to divide that by 25. All right, so you get 2624. So we get 26, 24. And then the last thing we do is we just divide that by 24 and take the square root of it. So we're going to take second square root 2624, divide 24. And what type of number should we get compared to the last standard deviation? Right? So remember last time we got 3.6 something? All right, we got 3.663. This time, we have the numbers a little bit further apart. So if we go through and execute this, we should get a number that's a little bit bigger, 10.456. So we end up with approximately 10.456, which is certainly bigger. And the reason, again, it's bigger is because if you look at your data, well, the range of values is from 100 to 50. All right, and that's a much larger range. Remember last time we had from 4 to 20, which is a smaller range. So just to kind of put it in context of the answers we should be getting. So hopefully this helps you to understand how to find the mean and the standard deviation of a sample for grouped data.